Today we'll start machine learning part of this course, and we'll start with a very simple technique in machine learning, which is called linear regression. Linear regression is nothing new actually; it was already there in statistics, and even if you take back your old NCERT class 11th mathematics books, you will find a chapter on it. Anyways, what is this linear regression all about? And before that, let's see that what is general machine learning model all about. We have discussed this in class, but let me tell it again briefly. So machine learning algorithm, you can treat as like a black box right now. So it may be something being programmed on a computer or on any standalone system, and it has one thing called input. Okay, and this box we will call as model, and there will be the output. Now there can be two type of problems. One is that given input, the purpose of model is to generate output such that we are able to classify. Okay, for example, you have a very common computer vision problems these days. We have to classify between human being, between animals. You have to classify different objects, or all of us now face camera when we are at any traffic light zone, and the purpose of that camera is to recognize the digits of your number plate and then take decisions based on you are crossing the road without green light, or you are having seat belt or not. So all of them can be done using machine learning algorithms, and the output there is to classify. There can be another purpose of this machine learning model, something to estimate. Okay, given the input, you may need to estimate the output. Okay, and a simple example I gave in the class also, suppose the input is your CGPA and your grades of different courses and other activities during your BTech. As a classification problem, it can be like, can this student get placement or not? Okay, this can be a simple. And what can be the estimation problem? That even if it gets placed, what is the average CTC this student can get? Okay. Let me give another example of classification. Suppose a patient takes a lot of tests, x-rays, CT scan, and other things, and with that we get some measurement. For example, in your brain we have some cells, you get the measurement of that. Based on that, we have to decide whether it is tumor or not, or whether it is cancer or not. So this is a classification problem. Another estimation problem, we can say, for example, you have different buildings or houses with some area given to you, and then what is the estimated cost of that house based on the area. Now what is done in machine learning is how this is being done. We basically have data. Okay, we call the data set. For example, I have given this example in the class also, but I repeat here. Suppose NIT Srinagar has the academic section, and we have the whole data of all the students, like what is the CGPA, what is the grade of different subjects, different semesters, or if the student has gone for internship, what is the performance of student in internship, if he has participated in some hackathons, what is the grade, and other things. Then we have all of you know we have placement cell, and placement cell has same thing. Suppose in academic section you have the enrollment number, which is the key of every student. In placement cell, against every enrollment number there will be a data of previous students, that first of all whether he has been placed or not, so yes, no, and if placed, what is the average CTC of that student. Now this will act as our training data set. Okay, we can train the model using this. Okay, but what is even done is this, like this. Suppose we have 1 2 up to, suppose, data of 1,000 students. Okay, what we will do is we'll randomly pick 500 of them, and then 500 other students. See, we have data of all of them. That is, what do we mean we have data? It means, suppose we have here enrollment number. Okay, like this. We have enrollment number, suppose 2020BECE something. Placed or not? Yes. What is CGPA? 8.54. Grades, so different grades will be there. So 10, 9, 7, 8, whatever. In different courses, C programming, Python programming, mathematics, electronic devices, communication system, all the grades. Average CTC, suppose 20 lakhs per annum. Similarly, other student. Okay, so like that we have data of suppose 1000 students. We divide it into two parts, 500 one set, 500 other set. Now what we will do is like this. We will pass on the input of first data set, first 500 students, and then also tell the model what is the output. That is, for example, you take the student number 1, will tell you that it has 8.54 CGPA, it has these different grades in different subjects, he is or she is placed and has 20 lakh per annum salary. Similarly, we will tell our model, will feed it 500 data points like this. Then what we'll do, so suppose this part of data set we have fed the system with input output. Now for the next 500 we will not feed, suppose let's say we want to just see if a student is placed or not, then we will not feed this answer. We will just feed that the student has CGPA 7.54, his or her grades are like this: 10 in C programming, 9 in maths, 8 in devices, 7 in maybe digital electronics, so on and so forth. Then we will let the machine learning algorithm tell us whether the student can get placed or not. Similarly, we will feed the same data and ask the machine learning algorithm what is the, if he or she will be placed, what is the expected CTC the student can get. Okay, now let's first study this estimation problem. That is, given the input we need to estimate the output. Okay, and this estimation problem is one of the ways, simple ways, is called linear regression. Okay, it's very simple. Let's first of all take a very simple case of one variable. Okay, let's assume that one variable is, let's say for example, CGPA of a student, or maybe area of building if we are taking the building problem. Let's take the CGPA example first. So what will be the relationship? In linear regression, we assume that the relationship between input output is linear. Something like this: y is equal to some theta 1 x plus theta 0. Okay, so what are these theta 0 and theta 1? They are actually some fixed constants, and in this jargon of machine learning we call them model parameters. And if you somehow get their values, you have a relationship between input and output. Okay, now one small point, why I'm using this notation theta 1 theta 2 is because I will be sharing with you in addition to my lectures a link to famous Andrew Ng, who was a professor in Stanford and the first person who introduced machine learning in the best way in the world via his free video lectures available on Coursera, and someone has uploaded them on the YouTube also. So we are going to follow the notation of Andrew Ng, so that if some of you revise from his video lectures also, you will be comfortable with that. Okay, now what is our job? See, this x is the input and y is the output. Okay, so theta 0, theta 1, which you will call as model parameters, later you will see we will call them weights also. So these are unknown. And how to get it? So we will have something called a data set like this. Suppose data set of NIT Srinagar is this, that you have a detail of every student, what is the CGPA grades of a student, and what is the placement status of previous students. Okay, they are placed or not. If placed, what is their salary or average CTC. Similarly, you may have a data set available at doctor's clinic about suppose someone has some X-ray or CT scan or MRI, what is the status of his cancer or any other disease. Similarly, you may have a data with real estate people that in different areas what is the price of a building with different area, I mean the area in meter square. Anyways, now let's see that how to estimate it. See, so let's first of all represent the data set. Okay, so let's represent data set in this way. I will explain the notation. You see, each element of data set are represented in this way. So input is x, and at the top superscript I am adding this x1 y1. It actually means first data point, okay, and second data point till this m, small m data points. For example, if you go back here, I have told that we have 1000 students and we break them into two parts, 500 and 500. And suppose first 500 students data we use for training the algorithm, so this m will be taken as 500. Okay, so in this case it is actually number of training points in the data set, and we will break data set into two parts. So this part is called a training data set. Okay, that is, this is used to train it. For example, if x is the CGPA, y is the CTC, so these x1 y1 x2 y2 xm y1, they will contain the known data points. Let's suppose if CGPA is 8.54, then this average salary CTC is 20 lakhs per annum, so the value of y1 will be 20. Similarly, if CGPA is 9.5, average CTC is 25. I'm just giving an example. So this way, these are the known values. Now, how to estimate the value of theta? So we are assuming the relationship like this, that let's say is input output are linearly related with each other in this way. So these theta 0, theta 1 are the unknown model parameters which we need to estimate given the data set. Since we are dealing with one variable, we can easily plot. Suppose we plot different data points and we find like this. Let's say it is from the start the 6, then 6.5, 7, 7.5, 8, 8.5, 9, 9.5, and so on and so forth. So we expect some relationship, not exactly this, but let's say these are the value of data points. Now what do we mean by linear regression? We are basically trying to find some line such that, see, we can draw different lines. Okay, let's draw a line like this. We can draw a line like this, but we want to draw the line such that these points are closer to the line as much as possible. So empirically, suppose if I draw a line like this, what we can say that x and y are linearly related almost in this fashion, because most of the points are closer to the line. You see, they are close to the line. Now, we, in one way, this is also called fitting this line in the data set. Okay, so that's what actually it was known earlier. Later we say that given the data set, we want to learn about theta 0, theta 1, hence the name machine learning algorithm. We want to learn about these model parameters given the data set. Now how to do that? You see, for any data point, let's say yi is the output and xi is the input. Okay, what is the actual output? What is the actual CTC? It is yi. But given xi, what is your estimate of the average CTC? Fine, so that is theta 1 xi plus theta 0, right? And this estimate, let's denote this as y hat of I. So this is basically the estimate. See, what do I mean? Suppose someone tells you, somehow using some genie tells you the value of theta 1, theta 0. Okay, that this is value of theta 0, this value of theta 1. After that, he tells you that the average the CGP of student is suppose 9.1. Can you estimate the salary without looking at the data set? Can you tell me what will be, what will be the average CTC of the student? So the best you can do is use this relationship and tell the estimate. Then that guy says, but I know his actual salary. Suppose you estimate it to be 18 lakhs per annum, but that guy has the actual data that no, it is not 18, it is 19 lakhs per annum. So there is an error. How much? 19 minus 18, that is 1 lakh per annum is the error. So let's define the error here. So error is y hat of I minus y of I. Okay, for various reasons which are already I have told you during the optimization class, because of convexity other issues, we would like to take its square rather than just the difference. Now this is the error when you are estimating average CTC for one student. What is the average error? So you just sum it up. I is equal to 1 to how much? M, and then this 1 by M will be the average. This is the average sort of error, also called average cost or also known as loss function. Now for some reasons which we will see very soon, rather than 1 by M, I will write 1 by 2M. It will become very clear why I am writing 1 by 2M. Okay. So now what is this the function of? See, y I hat, if you write it like this, is equal to, right, this linear relationship. So we can write this loss or cost as this also. Now you will see that this whole thing depends upon two unknowns, theta 1 and theta 0, because xi, yi is the data set point given to you. So it means this whole thing is function of theta 0, theta 1. And what would we like to do with this cost or loss or error? We'd like to minimize it. With respect to what? Of course, theta 1 and theta 0. Now go back to the importance of optimization. This is entirely an optimization problem. We want to minimize some function with respect to some variables. That is why we learned optimization. It is at the heart of machine learning algorithms. Without optimization theory, we cannot solve any machine learning algorithm. We cannot solve any machine learning problem. Now we need to denote this loss function by some variable. We'll follow again Andrew Ng's notation. Andrew Ng uses j theta 0 theta 1 as the notation. So this is your loss function or the cost function. And what is our objective? Our objective is to minimize this loss or cost, minimize this j of theta 0 theta 1 with respect to theta 0 theta 1. Okay, and now you know the solution from optimization theory. See, first of all, let's look at the convexity of this problem. You see, it's a square function of theta 0 theta 1, and hence it will be convex. Okay, so it means it has a unique global minimum. Okay, and you know the solution that you need to first find the gradient of j of theta 0 theta 1, put that equal to 0, that is del j upon del theta 0 del j upon del theta 1 equal to 0 0. Okay, let's find the derivative of j with respect to theta 0 theta 1. So here is j defined. Now what will be del j upon del theta 0? So this 1 by 2m is here, I is equal to 1 to m. So you know that first of all we have to differentiate. This is a square function which is 2 times this whole thing, and then internal differentiation. So of this term with respect to theta 1 will be xi. You see, xi is here constant with respect to the derivative. We are finding, I'm sorry, we have to find del j upon del theta 0. Fine. So theta 0 is here, there is nothing with this. Okay, so I will remove it. Xi will not be here, it is with respect to theta I. Okay, so this is the derivative with respect to theta 0. What is derivative with respect to theta 1? Okay, now it will be that which I wrote before this by mistake. So it will be, of course, you have the first 2 times theta 1. Sorry. So the internal differentiation is with respect to theta 1. Internal differentiation of theta 1 xi. Mind it here that xi is here constant with respect to the variable of differentiation. Theta 1 is the variable of differentiation. So internal differentiation of this whole quantity theta 0 yi is 0 because they are constant with respect to theta 1. So internal difference this term is x of I multiplied here. Now you put that equal to 0, what we will get? One more thing, why we had 1 by 2m, because of differentiation, this 2 comes here, 2 and 2 gets cancelled, we get 1 by m here. Anyways, now 1 by m, then okay, so first equation when we put greater than or equal to 0 gives this one, and the second equation gives. Now let's try to simplify these and let's see how to get theta 0 theta 1. In first equation what we will see is 1 by m summation theta 1 xi plus 1 by m summation theta 0 minus 1 by m summation yi equal to 0. What does it give us? So theta 1 is not depending upon the index I, so it will come out theta 1 by m summation I is equal to 1 to m xi. Now here theta 0 also does not depend on the index I, so you are summing theta 0 m times, so you will get m times theta 0 divided by m minus, now this is simply 1 by m summation I is equal to 1 to m yi equal to 0. Now what are these quantities? 1 by m summation xi, so these are all sample means. This is sample mean, and we can denote by x bar equal to 1 by m summation xi. And similarly, this quantity 1 by m summation yi is the sample mean of y. We can write it as y bar. So what we get is this equation, that theta 1 x bar plus theta 0 minus y bar equal to 0, where x bar is the sample mean of input points and y bar is the sample mean of output points. So this is the outcome of solving first equation, that is the partial derivative of cost function with respect to theta 0. Now the second equation is this. We'll try to simplify it. So this is the equation we get. Now let's simplify. What I did, I multiplied xi with all the three terms and then took a summation of all the t terms independently. I got this. Now the first term I can write like this, theta 1. Following the same notation, what I get by this term is sample mean of xi square. Okay, so let's represent this by x square bar. Okay, and this is the usual sample mean of x bar. This is the sample mean of xy multiplied, so I will call it xy bar. Okay, so we can write this equation in this way, then simplified, that theta 1 x square bar plus theta 0 x bar minus x bar y bar equal to 0. Now we have two equations. One is this, and the other, I will write this equation downwards so that we are able to capture it together. Now you have two equations and two unknowns, theta 0 theta 1. We can find it, and let's try to start simplifying it. So let's first put theta 0 equal to theta 1 y bar minus theta 1 x bar. Put it in equation 1. We get this equation because we replaced it theta 0 with y bar minus theta 1 x bar. Now let's simplify it further. So we get theta 1 x square bar, then x bar times y bar, then theta 1 times x bar whole square, and minus this. Now let's eliminate theta 1 and get the solution. Wait, I made a mistake. It is xy whole bar here. Okay, and theta 1 is xy whole bar minus x bar y bar divided by, so theta 1 is common between these two terms, so what will be divided by x square bar minus x bar square. This is the estimate of theta 1, and theta 0 will be equal to y bar minus theta 1 x bar. So from theta 1 you get from this, and then put it here, you will get theta 0. Now what is the importance of this equation? You see the quantities on the right hand side. Suppose theta 1, this x y bar, what is actually? It is a statistical quantity 1 by m summation xi yi I is equal to 1 to m. Xi, yi are the input output data points given to you. For example, xi is I is CGPA of particular student, yi is CTC of particular student. You just multiply it, sum it up for all students, you will get x bar, xy whole bar. What is x bar? It is sample mean. Okay, similarly x square bar, it is sample mean of x square, so on and so forth. So these quantities are computable using data, and theta 1 is expressed in terms of data set points, averages. So we can estimate theta 0, theta 1. Once we estimate it, we have an estimate of the relationship theta 1x plus theta 0. Now what will be the application of this particular linear regression model? If now you have a new student who just enrolled for the placement, he or she is in 5th semester, wants to get the idea what will be my expected CTC, just put his CGPA, you will get expected CTC. It may be a bad relationship. CTC does not depend upon only CGPA. It depends on other factors also, but this is just as an example. So I hope this with this simple example you got the basic idea of linear regression. I will have one short supplementary video with this for two purposes. One is we will generalize this to the multiple variables. Here we had just one input, we can have more than one input, and then we will also see how to implement it in Python. Yeah, thank you.